All right, well, let's go ahead and get started. We're going to be talking about getting started with Spinnaker Operator and Amazon EKS. This is what we're going to be going through today. So we're going to give you an introduction. This is a very intro-level talk. So if you're super familiar with Spinnaker, then we're going to cover some very familiar ground today. We're going to share some of our, some high-level concepts around Spinnaker and kind of what it's for, how to get going with Amazon EKS, and then how to go through the operator install and then configuration of Spinnaker itself. We'll also show you a little bit about your first deployment pipeline and where you can go from there. So who's going to be guiding you through this today? I'm Fernando. I'll be one half of the presentation today. I'm a software engineer at Armory, just delivering product innovation, I guess, in the open source space. And I'm joined here by my partner, Praseeda.
Thank you. So we met in the morning. So again, my name is Praseeda Sathaye. I'm Principal Specialist Solution Architect, and I work with strategic customers to manage their and help them with the application modernization and containerization.
So to lay the foundation for what we're going to be talking about the rest of the day, we're going to start real simple. So we're going to talk about the difference between CI and CD. Continuous integration are coming from platforms that you're very familiar with at this point, Jenkins, GitHub Actions, Circle CI, all these tools, right? And they're really responsible for getting you to the point where you have a deployable artifact. But what happens once you have that artifact? There's likely a whole bunch of constraints that you have to work with when you're sending that artifact into an environment where you're going to get consumer level traffic, right? So let's say you have a microservice that you've been developing for some time, you want to send it to a production environment. What do you do with that Docker container or that jar file? That's where Spinnaker's sweet spot is. So Spinnaker gives you the ability to describe imperatively all the things that you need to do in order to ship that artifact to somewhere where your users can actually access it. So we're not going to go through this whole diagram just at once. We're actually going to go piece by piece. So we're going to talk about the first element today. How do you actually get a Spinnaker cluster running? We're going to use something called the Spinnaker operator, which is this open source Kubernetes operator that's going to help you manage the lifecycle of Spinnaker clusters in your environment. So we're going to use Kustomize to help us manage all of that configuration today, pass it off to the operator, and then have it create all of the resources that constitute Spinnaker. Now, your users, when they actually get into Spinnaker and they want to start doing deployments, they're going to want to pull artifacts from a number of different sources. So Spinnaker gives you the ability to define artifacts in GitHub, in ECR, Elastic Container Registry, and a whole bevy of other tools. But today we're going to focus on these two. And then once you've got those artifacts that you're ready to deploy with, we build pipelines, which are composed of stages, which are composed of tasks, that allow you to take that artifact and describe a deployment to that environment. So for example, if you wanted to take a Docker container that you wanted to ship into a Kubernetes cluster, you describe a build or pull from a Docker registry or from a Jenkins build, that Docker container, bundle it up with your Kubernetes manifest, and then apply it to the cluster. And then maybe you want to add a little bit more on top of that. Maybe you have policy constraints within your environment. You want to make sure you're adding labels. You want to make sure you're adding, or you're not exposing any ports that you shouldn't be. These are all things that you can describe as a part of a Spinnaker pipeline. And then of course you can also deploy to a number of other targets. So that's another strength of Spinnakers, where you can not only deploy to a Kubernetes cluster, but you can also deploy to Amazon. You can deploy to Azure, Google Cloud, all these different environments that you likely have within your organization today. So with that, I'm going to pass it off to Praseeda to talk a little bit more about the demo that we're going to go through today.
Thank you. So you know everything now, the cool things what we discussed about the Spinnaker, just we talked about. So let's see how we can use this in our use case today, and we'll tie everything end to end. So we'll talk about persona-based delivery, as most of our AWS customers follow this as a guiding principle for continuous integration and continuous delivery lifecycle. Here what you see is the platform team persona. They are the admins, central team, the ones who put guardrails to empower their developers in the organization and make it easy for the application development team to onboard new application or release application faster. And this team will be responsible for the setup and installation of all the tools and infrastructure required for the development teams to work and very easily, right? So for our use case here, this team will be creating the EKS cluster using the EKS blueprint. I'll talk about this in a minute. Next, they will be responsible for installing the Spinnaker operator, which Fernando already went through. And Spinnaker, as you all know, is many microservices that perform different functions, right? So we'll be using Customize to create these Spinnaker services here. So, and we are also going to use Customize patch configuration feature for integration with different AWS services. For example, if you see on the left-hand side, we will configure S3 to persist the metadata of Spinnaker applications and pipeline. And then we will be configuring the load balancer to expose the Spinnaker UI. We'll also be configuring the Amazon ECR as the Docker registry. And Fernando will go through all this configuration during the demo. So I want to quickly highlight about Amazon EKS if anyone is new over here. Basically, it's a managed Kubernetes service at AWS, and it provides the flexibility of Kubernetes with the security and resiliency of being a AWS managed service. Amazon EKS is fully Extreme certified and conformant Kubernetes. What does that mean for customers? It's like they can migrate their self-managed Kubernetes platform. If it works there, they don't need to re-architect. It will work with EKS. And Amazon AWS support Kubernetes versions longer than the upstream community to give the customers more time to plan and roll out their upgrades. It currently supports 4 Kubernetes versions. As you see over here, it's from 120 to 123. In a nutshell, goal of Amazon EKS is to make Kubernetes operation very simple and help customers run Kubernetes in trusted and secure way. And if you are interested to learn about Amazon EKS, we have a Containers Day session tomorrow as part of KubeCon. So please do attend that if you are over there. Then now moving on to the EKS blueprint, and this is the one which we have used in today's demo to create the EKS cluster. This was released like few months back, so it's brand new. That's why I wanted to introduce this. This is basically an open source framework that allows customers to configure and deploy complete EKS clusters based on the AWS best practices and recommendation. So what do you mean by complete EKS cluster, right? It's a cluster that is bootstrapped with all of the operational software and add-ons that a customer will need in order to run their workloads at the end of the day. So implementation of this EKS blueprint is via infrastructure as code, and you can use it in Terraform or CDK. For today's session, we have used the Terraform one. It has a wide range of popular open source integration as pre-built modules. You can check it out. We have Argo CD, we have other like Flux CD and all those modules as part of this, which customer can just enable to use it. And it's fully extensible as it's implemented as infrastructure as code, right? So customer can take it, they can enhance it, change the module based on what their requirement is. And again, if you want to learn about EKS blueprint, we are going to have a couple of sessions during the reInvent. So if you are over there, please feel free to attend. Okay, so earlier we talked about the platform persona, right? And this is the persona from the development or DevOps team perspective. So these two teams can be the same or can be different. It's based on your organizational size or based on their requirement, business functionality. But their main focus is to develop, test, build, and deploy the application. They do not care about setup or tools required for all these things, right? So in our scenario here, down there, the DevOps team will build the Spinnaker pipeline with different stages. And as you see, the stages are from configuration, bake, promote, and deploy. And then we will, from the developer perspective, he or she will be only focusing on making sure the application is running fine, they're developing. So as soon as they push the code changes, and it will go through the CI, continuous integration process, and then that it will push the Docker image to the Amazon ECR. Amazon ECR is AWS managed container registry, and as soon as the image gets landed into ECR, it will trigger the Spinnaker pipeline, and this artifact is going to get used in the entire stage over here. And we are going to use the this image artifact will be based on the test deployment spec using the customized overlay for dev. As you see over there, it will pull that information from that Git. And then the deployment spec will be used to deploy the application to EKS test environment. And we have an approval process. We have set it over here for the manual intervention. And once that approval is done, it is going to move to production. And that's what we are going to show you in part of our demo, which is the coolest part of this session. Okay. Okay, as I mentioned before, we are going to use the EKS blueprint. And if you see, like, this is the blueprint what we have used. So the form of blueprint what we used is like creating a new VPC, but you can still use the existing VPC blueprint as well. It's available here. So once you clone this repository, then you can basically do Terraform init, and then you can target apply to create the VPC, EKS cluster, and all the add-ons what you require for this. Okay.
And so we've already run this step for you because as you've probably seen if you've tried to stand up EKS4 before, it will take a little bit of time. So we're going to switch back to our code here, and we're actually going to dive into a little bit more about Kustomize and the Spinnaker operator. So once we have an EKS cluster, the next step that we need to worry about is how do we actually get Spinnaker running in our environment? So we're going to use a combination of Kustomize and the operator today to get to that point. So if you're new to Kustomize, it is one of many tools within the ecosystem that can be used to manage configuration within Kubernetes. A couple other popular ones are like Helm, Kepton, maybe not Kepton, Scaffold is the one that I was thinking of. And they're all meant to manage the complexity of all of these YAML files that we're shipping over to Kubernetes. So for today, we're going to be focusing on Kustomize, and Kustomize's strong suit is less on providing a shrink-wrapped packaged experience for installation and more on providing you the ability to define very precise edits within a YAML document. So what we see here is a Kustomize manifest. If you're familiar with older development tools like Make, this is the equivalent of like a Make file, right? Which is basically describing the things that we want and the places that we want them to go. So we've got our customization here. We're going to specify our namespace. So today we're going to be installing Spinnaker in the Spinnaker namespace. And then we've got this notion of components here. Now, if you are familiar with Kustomize, this may be less familiar to you. So components are a feature that was introduced in Kustomize 4, and they give you the ability to bundle a number of different customized resources into something that you can essentially import. So what that looks like is, if we go into any of these files, is you can define the same resources that you can define inside of a customized file, but you can instead pull them in completely, right? And the benefit here is that if you have a partial patch, for example, if you have a partial Spinnaker service definition, you don't have to bind it to a resource in order to be able to reuse it, which is very nice in this case because what that allows us to do is to break up our components like you see here. So we have a core component, which gives us the base Spinnaker service CRD. Then on the next line here, we have our default Kubernetes target. So this is going to create a service account inside of the Kubernetes cluster where we're going to install the operator and Spinnaker. We're going to be able to define a persistence layer here, which is going to allow us to store our application and pipeline metadata inside of S3. And then we're going to define a Docker artifact, which is going to allow us to pull images from an ECR registry. So what's really neat about the component approach is that it allows us to bundle up a lot of this configuration in a way that abstracts the complexity of this configuration to the end user. So if you are a platform team of platform teams, or if you're even just trying to share a lot of this configuration across individuals on your team, you don't necessarily need them to understand every single configuration file that's going in. You can kind of bundle it up according to the unit that you're trying to apply. And this allows us to easily swap out, for example, if we wanted to go to an in-cluster persistence layer instead of S3, we can easily swap the components here and then do a migration of data from those two data sources out of band here. The last thing I'll mention about components is that, as you can see here, it allows us to pull from a Git repository. So if you want to share configuration across clusters, common configuration across clusters, you can do that. And you can also reference, like you see here, a branch on that repository, so you don't always have to keep something in the same repository that you are installing in. So what we're going to do is we're going to show you what some of the patches are inside, not inside of these components. So the simplest one that we could possibly show you is a version definition. So in this case, this is all we need to define in order to change the version inside of Spinnaker service definition. So here we're pulling the 129 release, and the way that Customize knows how to install that or apply that to the rest of the cluster is through this patches strategic merge field. So this is going to allow us to declare, hey, this is a snippet of config that I want, and I want you to add it into this base definition that we've defined up here. The next thing we'll show you is an S3 bucket. So if you follow that EKS blueprint, it's going to have you create a service account for Front 50 to actually store all of this information in S3. So this gives us the ability to specify the service account that we're going to use, along as the bucket that we actually want to store data in. Then the next thing that we want to look at is our Git repo and ECR patches, because the ECR patches are a little bit more complex. So let's quickly look at Git repo. Here we're essentially saying, I want you to go to GitHub, and I want you to use this token that I've stored in GitHub, and be able to, or allow my end users to retrieve information from Git repos that I provide access for within that token. And then finally, the last one that we want to show you is the ECR registry, because this one looks a little bit different than the other customized patches that we've seen. So in certain cases, edits become difficult within Customize, and so they provide you a JSON, a way to define a JSON path in a value that you want to replace, so you can get even finer grained with the changes that you want to make. So in this case, we're making an edit to the first account that we've defined for Docker registries. We're going to be pointing to an ECR registry, and then we're going to point to the particular images that we want to pull. And then the last piece that is really neat here, if you are new to the Spinnaker space, is the ability to define a way to retrieve credentials for pulling those Docker images. So Amazon, of course, provides a number of ways for you to access resources in a least privileged manner. So in this case, because we are using a private registry, we need to tell Spinnaker how to pull credentials for those Docker containers. So we specify the command here, which is essentially getting an authorization token and formatting it a little bit with the tools that are on the container to be able to get that token and authenticate requests to ECR. So with that, let's go ahead and apply this to our cluster. So I'm going to move down here and do this all one-handed. We're going to go, actually, the first thing we need to do is install our Spinnaker operator. So let's go ahead and do that. I'm going to go ahead and grab the command here. And our Spinnaker operator is essentially a set of manifests. I'll go ahead and make this split a little larger. Okay, and what we're able to do here, oh, this might mess up here. Let's go ahead and try this again. And what this is going to do is it's going to download the manifests into my local environment, and then I'll be able to apply them after we've got them out. And while this is downloading, I guess I'll talk a little bit about what we're going to do once this is all downloaded. So you're going to get a bundle of custom resource definitions and manifests that operate on those custom resource definitions. So CRDs, or custom resource definitions, are a way for you to extend the Kubernetes API. What the operator does is it defines that Spinnaker service manifest that we've just been looking at, and then the operator itself hooks into events that are created around those objects. So anytime I apply a Spinnaker service configuration, the operator is listening to events, recognizing that there's a change, and then it's going to reconcile that change inside of the cluster. And I'm not sure why this isn't downloading, so luckily we've got it all locally already. So we've got it in this deploy directory, and I'll quickly show you what that looks like. So you can see here, well, we're going to look at it a little bit dark here, but you can see that we're essentially just defining all of the kinds of things that we accept for a Spinnaker cluster to be created. And what's nice about this approach is that you can basically describe, I want a Kubernetes cluster that is version 129. I want it to have these values, just like we've seen with our ECR registry and our GitHub repository, and then the operator figures out how to stand the rest of it up. And what it's actually going to do is it's going to take that configuration, that declarative configuration, and then split it into configuration files and deployments for all of the services inside of the Spinnaker ecosystem. So I'll quickly show you what that looks like here, and then we'll talk through what it's doing behind the scenes. Okay, so as we can see here, we've got all of our Spinnaker services running. And what the operator has done behind the scenes, assuming we had just applied all of our configuration here, is that for example, the GitHub configuration, for example, that was turned into settings that CloudDriver understands. It creates a config map and then, or a secret in this case, and loads it into that CloudDriver pod. So these are all things that you can configure on your own, or you can kind of let the operator do it for you. And then it's going to do that for each and every service on down. And there are some more complex configurations that you can define that will generate configuration for multiple services. And in that case, instead of you having to manually remember, hey, I need to go restart these N services, the operator is going to recognize when that change needs to happen, and it's going to restart those services on your behalf. So what we've ended up doing is once we've applied this service, we've actually defined it with a load balancer. So we've got it up over here, and I'm going to make this a little bit larger. And then we're going to move into our application demo here. So I will hand it off to Praseeda to guide us through the application.
Yeah, so in the interest of time, we have already created the pipeline over here, which you see Spinnaker Summit 2022. And we'll see what all stages we have created in those, in the pipeline. So as I showed in the diagram, we have configuration, which basically pulls the information from the ECR, what we have set up before. And then in the next stage, bake, test, manifest, we are looking to the GitHub repo for our application, and we are looking at the overlay test customization YAML because we are deploying it to the test environment. So everything is handled via customize here. And next, going to the deploy, it will use the manifest, whatever is there, and it will deploy. And we have added again the next stage, which is for us, someone showed before, like we need stakeholders to actually decide on whether it can move to production. So we did add that. And then similarly, like for the bake production manifest, it is going to look at the overlay production customization YAML to deploy those to the production environment. So let's run this as a developer. We'll push the changes, and it will actually create the container and push it in the ECR. So it's going to run this. OK, you want to show that on the lens? OK, so it is running, and now we will go back and apply it to production. OK, and it's running. So now this is just a manual thing we have shown, but now we are going to show it in the real world scenario where you will have like continuous integration process via Jenkins, and then it's going to do the build, testing, and everything, and make sure that it has the image pushed to the ECR repository. So that's what it is doing over here. And now this, as soon as it lands in the ECR, you should see the build triggered over here. The pipeline should get triggered. And waiting. OK. OK, assuming that it will trigger the pipeline and it will go to the same cycle. Oh, OK, here you go. So it's going to take the build, what we just pushed through CI process 1.50, and use that artifact for all the stages over there, and then deploy to production. So going back to the slide. Okay, and if you are interested and excited about this, please feel free to look at this information over here. The first link actually points to EKS blueprint that we have used for today's demo. So you can contribute as well if you want to contribute any modules into it. It's based on both Terraform and CDK. This link is for Terraform. And the second one is the EKS workshop that I publish for our AWS customers. To get started on. It has like all the basic features of EKS, so it really works for the immersion days for the customers. And the third one is the EKS best practice. When you are really starting with EKS, this is the right place to go because it has different modules based on security, networking, and reliability, where you can check like how to get started with the EKS cluster.
And then finally, if you're curious about the resources that we use today in this workshop, they're published in this repository as well. We'll go ahead and get the slides published on Sketch as well if you want to go look at that or take a picture of the screen. The other repository that we'll highlight here is these customized patches repo. So this is a set of components that we've been building out that manage a number of common configuration use cases when you're trying to get Spinnaker up and running. And lastly, we'd love it if you were inspired today by this talk or any of the talks that you've seen today to start contributing to the Spinnaker community. We link to the community pages here. There's a number of ways to get involved. If you weren't in the TOC this morning, it's as simple as filing an issue. It's as simple as joining Slack. The barrier is low to get started, and we'd love to help you contribute more to the project. So at this point, we'll open it up for questions, and thank you very much for walking through this demo with us. Questions? Are there questions virtually? I don't know if we have anyone monitoring the virtual. Come again? Is the question, is the installer open source? The answer is yes. So there's a Spinnaker operator that's open source. We also have one for our Armory product, but that's not the focus of today. It's really the open source Spinnaker operator. And those customized patches are open source as well for you to use. Yes. Yeah, excellent question. So to repeat it for the stream, the question was, are there other benefits to the operator besides just restarting services? And the answer is yes. So the operator currently manages secrets on your behalf. So you can store secrets in S3, you can store them in Vault, you can store them in Kubernetes itself. So if you wanted to, for example, store that GitHub token as an opaque secret inside of the cluster, you could do that and reference like a special string inside of that service config, and it'll get resolved before the application is actually stood up. So you have like a consistent experience depending on what your backing secret store is to define secrets within the cluster. There's also a few other things that it'll do, like for example, it'll help you stand up the load balancers. Of course, it's just an annotation on the service, but if you have more complicated setups, then it'll try and do some smarts there to help you out. And you know, there's just all the benefits of the operator, I guess, pattern within Kubernetes are patterns that or benefits that you would get, and you know, it's something that we want to continue contributing to and growing in terms of like what it helps you do. Ultimately, right, like. I can't remember how long ago this was, but one of the ideas behind the operator pattern was to encapsulate as much human operational knowledge inside of that software. So the more best practices that we determine in terms of like running and operating Spinnaker, the more that we put into that operator, the better it'll become and the more useful it'll become for people that are new to the space. Other questions? Great. Thank you very much.